Our last section in this chapter is on statistical inference. A set of measurements or observations in a statistical study is said to be statistically significant if it is unlikely to have occurred by chance. The common levels of significance are at the 500th level, or 5%, or at the 1/100th level, which would be 1%. Are all the events statistically significant? And explain. So the Major League Baseball team with the worst in-loss record defeats the team with the best record. Well, this is, if you are a fan of the team with the worst record, and all of a sudden they win, that's really cool for you. But we expect a team with a poor record to lose most of its games, but even then it'll win occasionally. So this is not statistically significant. In terms of the global average temperature, the 12 years from 2001 to 2012 were 12 of the 14 hottest years on record since 1880. Well, if 12 of the 14 hottest years on record in a total of 132 years were in the past 12 years, that's unlikely to have occurred by chance. That is very worrying, and it is statistically significant. A researcher conducts a double-blind experiment that tests whether a new herbal formula is effective in preventing colds. During a 3-month period, the 100 randomly selected people in a treatment group take the herbal formula, while the 100 randomly selected people in a control group take a placebo. The results show that 30 people in the treatment group get colds compared to 32 in the control group. Can we conclude that the herbal formula is effective in preventing colds? Well, a difference of 2% is not really big enough to conclude that the people are getting colds for any reason more than chance. It's only a difference of 2%. So it's not statistically significant. So we should not conclude that the medicine makes any difference. The margin of error for a 95% confidence interval is 1 over the square root of n. The 95% confidence interval is found by subtracting and adding the margin of error from the sample proportion. You can be 95% confident that the true population proportion lies within this interval. The margin of error decreases as the sample size increases. So the more people you interview, or the more people in the experiment, the smaller the margin of error. Suppose the Bureau of Labor Statistics finds 3,420 unemployed people in a sample of 60,000 people. estimate the population unemployment rate and give a 95% confidence interval. So the sample proportion is the unemployment rate. And that would be the number unemployed out of the number of people in the sample. So 0.057. The margin of error is 1 over the square root of the sample size. That's 60,000. So 0.004. So we can find our confidence interval by taking 0.057 and subtracting our margin of error and 0.057 and adding our margin of error. So that would be, 0.053 to 0.061. So we can estimate that with 95% confidence that the unemployment rate is between 5.3% and 6.1%. And that concludes the section.